And moving on to the next part of our discussion on simple circuits, we have the concept of Kirchhoff's rules. Kirchhoff's rules are two rules that when applied to a circuit will give you a set of equations that you can use to analyze the circuit and thus determine the unknown quantities. These two rules are the junction rule and the loop rule. For you to apply the junction rule and the loop rule, you need to be familiar with what a junction is and what a loop is. A junction is a connection point in the circuit, a connection point of three or more wires or lines. For instance, if this is our circuit, this point is a junction. You have 1, 2, 3 lines connected at that point. You have a junction, a connection point of 3 or more wires or lines. This is also a junction. 1, 2, 3 lines connected at that point, you have a junction. A closed loop, on the other hand, or simply a loop, is a closed conducting path. You start at one point in the circuit and then go around the circuit until you return to the starting point. You start at this point, then go around the circuit until you return to the starting point. You have a loop. So this is one loop. This is another loop. And this is also a loop. You have a junction and a closed loop. Now that you are familiar with what a junction is and what a loop is, let's go over the two rules of Kirchhoff's rules, the junction rule and the loop rule. Starting with the junction rule. For the junction rule, also known as the current rule, because in the junction rule, we look at the currents in the circuit. For the junction rule or the current rule, apply the following equation for each junction in the circuit. Summation of plus minus I is equal to 0, where I is the current or currents associated with the junction concerned. Summation of plus minus I is equal to 0. If you have several currents associated with the junction, this will give you plus minus I1, plus minus I2, plus minus I3, and so on, equal to 0. Plus, minus, use plus if the current is heading toward the junction. Use minus if the current is heading away from the junction. For instance, consider the four circuits or four currents rather as shown in the figure. You have 1, 2, 3, 4 lines or wires connected at this point. This point is a junction. With this junction, we have four currents associated with this junction. You have I1, I2, I3, and I4. I1 is leaving the junction. I2 is heading into the junction. The same goes for I3, heading into the junction, whereas I4 is heading away from the junction. Applying the junction rule and the plus-minus sign convention, we get minus I1 plus I2 plus I3 minus I4 is equal to 0. Minus I1 because I1 is leaving the junction, heading away from the junction. The same goes for I4 minus I4. I4 is leaving the junction or heading away from the junction. On the other hand, plus I2 plus I3 because I2 and I3 are both heading toward the junction. You have the junction rule. Summation of plus minus I is equal to 0. Apply this equation for each junction in the circuit. For the loop rule, which is also known as the voltage rule because in the loop rule, we look at the voltages in the circuit. For the loop rule or the voltage rule, apply the following equation for each loop in the circuit. Summation of plus minus V plus summation of plus minus IR is equal to 0, where V pertains to the voltages due to the EMF sources or power supplies in the circuit or in the loop, rather, and IR for the voltages across the resistors in the loop. Summation of plus minus V plus summation of plus minus IR is equal to 0, which gives you plus minus V1 plus minus V2 plus minus V3 and so on, plus minus I1 R1 plus minus I2 R2 plus minus I3 R3 and so on. For V, plus minus, for V, use plus if the loop enters the positive terminal of the source. Use minus if the loop enters the negative terminal of the source of the voltage source. For plus minus IR, for IR, use plus if the loop and the current have the same direction. Current I, IR. Use plus if the loop and the current have the same direction. On the other hand, use minus if the loop and the current have opposite direction. Whether you are looking at V or looking at IR, it's important to take note of the loop direction of the loop itself. To avoid mistakes, be sure that if one loop is clockwise, all the other loops in your analysis must also be clockwise. If one loop is counterclockwise, then all the other loops must also be counterclockwise. Be consistent with your loop direction. For instance, consider the loop shown. We have the following circuit. We have voltage V1, voltage V2, and resistance R1. And in this particular part of the circuit, you have current I1 flowing through the wire. Starting at this point, then going around the circuit, and we end up back at our starting point. We have one loop. Starting at this point, the loop enters the negative side of V1, so minus V1. Then it passes through R1. The loop at this location is heading to the right. The current is heading to the right, same direction, so plus I1 R1. Next, the loop enters the positive side of V2, so plus V2. Then we end up back at the starting point, equal to 0. You have the loop rule application for this loop. In some problems, the current directions will be indicated, in which case, use the direction of the currents as is or as given by the problem. But in some problems, the current directions will not be indicated, in which case, you yourself would have to assume the current directions. This is not an issue for Kirchhoff's rules. If you have assumed the wrong direction for the currents, the current that you will calculate will be negative, meaning the direction of the current should be in the opposite direction. So correct the direction of the current and do the analysis again. So no problem in assuming the direction of the current for Kirchhoff's rules. And that's it for now. That's it for our discussion on Kirchhoff's rules. We'll continue our discussion on simple circuits in the next video. In the next video, we'll take a look at a few examples. So again, that's it for now. Thank you for watching.